Hello and welcome to another Clojure Diary. So today we are going to look into numbers. So let's see how numbers in Clojure work, right? So okay, fine. Right. So I just have a number over here. It's just 17, right? So I just execute it. It works. You get 17, and I just have this number 017, and you will expect it's still 17 but it's 15, right? So why so? If you put 0 before a number, Clojure thinks it's octal, not a decimal number. And I think this video is beyond scope to explain what is octal and all those stuff. Okay, so you need to refer that. So, but yeah, like don't put 0 before numbers if you don't know what octal is and if you don't want to represent something in octal format. And let's see what will happen if you put O before a number. That will give an error. So don't think like if you can just put O for a number and it will get converted to octal. That won't happen, right? So that's the thing. And now over here, I've just put like 0.17. Okay, so if I execute this, some people will think like, okay, you will get 0.15, but it's still 0.17. This does not become octal. So now let's try it at 0.17. Still, it's 0.17. It's still decimal. It's not converting into octal, right? So please remember that. Okay, so that's it, right? And now, okay, I can even put octal like this one. So radix 8, or you can just put 8R like this, and you'll get this 15. Okay, so 17 in octal is 15. Okay, so that's the thing. So which means like 5 plus 8, which is equal to 7. Sorry, like uh okay, yeah. So like yeah, I mean 17 is in octal is 10 in what to say, like okay, I messed up. Okay. 17 in octal is 15 in base 10. So how it works is it's like this. Okay, it's 7 plus 8. That will become 15 in base 10. Okay, so for hexadecimal, you can put 0x. Okay, so that's how it works. Okay, so 17 in hexadecimal is 23 in decimal, and you can even put small x. No need to put 0 and capital X. Okay, you can also put small x. Okay, so that's the thing. And okay, you can also put like 16R and then 17. You'll still get 23, right? And then you can also put this capital R. Not a problem, right? So that's how it works. So all other things doesn't work. Okay, if you put like 16R minus 17, it works. No, right? I didn't try this out. Okay, so like let me just try this out. Minus 16R7. Will this work? Ah, yeah, this works. Okay, and similarly, yeah, this will give an error. So this will give an error. And so I think I need to put like minus 0x 7, right? So that's the thing. And if I just put like 0x 17.34, it will give an error. So you can't put floating points, but I don't know why. So, usually this Clojure follows Java. Whatever this Java gives, Clojure follows. So, because Clojure is a hosted language. So you can't say, okay, this weirdness is because of Clojure. Yes. Maybe if you can design a language that's more mathematical and more human friendly than Java, and if you can make Clojure work on top of it, then it should be good, I think, right? Yes. And yeah, even trying to put decimals over here gives you an error. Now, look, let's say whether you have this 16, 17, you even have this octal, that is radix 8. So let's see whether if you have like radix 7. No, you don't. Okay, there are only few radix that's been supported. Even radix 4 is not supported, but yeah, this is giving an error because of different reasons. So, yeah, I will rectify this one. I can just put, okay, 4 supports only 0, 1, 2, 3. So I can just put like 3, 3, 1, 2. So this will work. So 46, right? So this is 2 plus 1 into 4 power 1 plus 3 into 4 power 2, and then and then 3 into 4 power 3. So that's how it is. And it also supports this more than what is it, like, uh, weird stuff like radix 32 plots. It's 127 plots. So you just put 3V, and what does V stand for? V stands for 31. So and this, how it works is it's like, okay, like uh, 31 plus, so, and then what it is, okay, like 3 into 32, 3 into 32. So this is how, so 127. So that's how it works. And yeah, this is of radix 2, 1101, 30. And this exponential notation, okay, if you are into mathematics, you will know this is 17 into 10 power minus 1. So it's 1.7. And yeah, it's just 17 into 10 power 1. That's like 17 into 10, which is 1 second. This is 17 into 10 power 0, which is 17. It's like 17 into 1. Okay, but note that, okay, this gets converted into floating times. Okay, so that's it. No matter whatever you do, it just gets converted. Oh, I think you call it as decimal. Yeah, this is 17 into 100, and you can also put this capital E. And this M means arbitrary precision, and we'll look into it further down the file. So the type of 17 is what to say, it's just long. That is just, it is represented as long in Java. And the 17M is represented as big decimal. This M means actually arbitrary precision, and the 17N is okay. It's represented as big int. You can store bigger integers. Okay, so and if you just put some number like this, okay, so and if you just look at the type, it is big int, very large number, and it just gets stored like nothing gets truncated or something like that. Okay, so that's how it is. Okay, so let me just wrap my text over here. Okay, so nothing gets truncated and all this. But if you put decimal, look, this is a huge decimal over here. So this is a huge decimal over here. So over here, there is a point over here. Between this 5 and 2, there is a point. So let me execute this. Now you see it's been truncated. It's some number and then e power 32. That is like 10 power 32 actually. I don't know why they put e. And e is also another constant like for natural logarithms and all those stuff. I don't know why they put e, but yeah, anyway. So that's how we are being represented. So now I have this number and this is being preceded with m. So at the last, can you see an m over there? So now it's execute this one and nothing gets truncated. So M means arbitrary precision. I don't know how they implemented it. So, but for scientific computing, it should be very useful, right? So, yeah, arbitrary precision and whatever you just put, you'll just get. And if you just put, yeah, it is of course decimal, right? You also saw this before. I think we saw it over here. And you can even multiply it and do all sort of crazy stuff and still holds the precision. Okay, so that's the thing. And so yeah, these are the things I just discovered about Clojure. Yeah, like while I discover more and more detail, I'll be putting more and more videos. Anyway, thanks for watching. Until we meet next time.